Before we talk about what I have here, I do want to make mention of one thing here where it's the sort of at face value nonsense mathematical statement that a lot of people who aren't mathematically inclined don't like to see, and that is the matrix 2 is not the same as the number 2. That is, if we're looking at the matrix of order 1 by 1 that consists of only the number 2, its element is equal to 2. But even though this is a very small matrix, it's not the same as just being the number. It's a slightly different construction, and as a result, it does a vitally different thing when we talk about multiplication. But anyway, with this in mind, let's think about what it means to multiply an equation by a constant. Let's say we have something like x plus y equals 7, and let's say we multiply that by 4. So we would get 4x plus 4y equals 28. And meaningfully, we haven't changed that much, but we do cause that equation to, in a sense, move much faster. We cause it to grow in a different way. We rescale that equation by a factor of 4. Hence, when we talk about that sort of thing, we talk about it in terms of what's called scalar multiplication. And the distinction between scalars and vectors is something that we'll see a bit more later on, that we'll see, I believe, in Chapter 6. So it's kind of paradoxical to say that we're seeing Chapter 6 after Chapter 8, but that's how we're structuring things this semester. Anyway, the point is, when we multiply by a constant, we can think of it as a rescaling by a factor, and multiplying a matrix by a constant works in much the same way, where if we multiply a matrix by a constant, that is, for some constant c and a matrix A, we can write this as being the constant c times the matrix of our elements, ij, or if we want to be a little bit more specific about it, we can think of this as c times each of the elements. So in the same way that when we did addition and subtraction in terms of each separate term, we can perform multiplication by a scalar. That is, we can perform scalar multiplication term by term. And before I get to an example, I do want to point out a couple of basic rules that this follows first, which kind of come from standard algebra, as it were. So when we have two constants, c and d, and we're thinking of multiplying them by our matrix, we can either group them together, or we can group one of those constants off with the matrix. If we multiply the number 1 by a matrix, we just get the matrix. If we look at what's called a linear combination, we can split that up, and then we can split up and distribute in terms of constants as well. So if we have c times a sum of matrices, we have c times each. And if we have a sum of constants, c plus d times a matrix, we can split that into c times a plus d times a. But in any case, let's look at a couple of examples here for how we can put together these ideas of scalar multiplication and addition subtraction. So let's say we have the matrices A equals 2, -1, 3, and 0, 1, 5, along with B equals -3, 6, 1, and 1, 4, 2. So these are both 2 by 3 matrices, where we want to compute 3A, 2B, and 2B minus 3A. Essentially, we want to put them together. So for this, what we're going to do is much like with the addition subtraction, take things in terms of each of the pieces, just going through carefully. So starting with 3a, we can think of that as 3 times the matrix A. And then we can think of that as 3 times each of the terms taken one by one. So 3 times 2, 3 times -1, 3 times 3, 3 times 0, 3 times 1, and 3 times 5. The scaling gets hit on every single piece, just like when you're multiplying a constant by an equation, that value is going to hit every single piece. And the result will be the matrix 6, -3, 9, and 0, 3, 15. 3 times every single one of those values. Meanwhile, for 2b, we would have 2 times the matrix, which is 2 times -3, 2 times 6, 2 times 1, 2 times 1, 2 times 4, and 2 times 2. 4, -6, 12, 2 in the first row, and 2, 8, 4 in the second row. And then finally for our third piece, if we take the 2 that we did and put them together to take 2b minus 3a, we're taking that matrix from 2b and subtracting from it the matrix 3a, which means going piece by piece. -6 minus 6, 12 minus a -3, 2 minus 9, 2 minus 0, 8 minus 3, and 4 minus 15 for a 2 by 3 matrix, a matrix of order 2, 3, just like what we started with, but it will have form -12, 15, -7, and 2, 5, -11, where again, all we're doing is taking our pieces and going through carefully one at a time. Each of these operations works in very much the same way, piece by piece. Just be careful with that basic arithmetic. The next thing we're going to look at, though, takes it in a different and I'd say more intense direction, where we're going to look at matrix multiplication, and we're going to start that in terms of 2 by 2 matrices so that we can get a feel for the pattern before moving on to the more advanced stuff with general matrix multiplication.